Hi, you are welcome to the second day of the 7 days summer coaching. I want to believe you had a nice time in the last class. So the last class we discussed about logarithms. We look at the definition, we solve one or two questions, and you are also given some assignments. And don't forget, the last class we said logarithm of a number to a given base is the power to which the base must raise to give that number. All right, so today we are going to do the correction to the assignment given to you. Now, before we dive into the class, now I would want you to tap your like button and also share this video with your friends. Thanks for doing that. All right, now let's look at the question. You have to solve for x in the following questions. Now, you have log of x big square root of 5 equals to 4. Now, how do you solve this? This is a logarithmic equation. So you change it to initial equation. Now, the last time we said when you have log of n base x equals to p, this is a logarithmic equation. It's going to give you n equals to x raised to the power of p. All you just need to do is just to move this x, which is the base, move it here, and you take away the log. All right, so we are changing this logarithmic equation to initial equation. So we want to express this in this form. So now this will come here. So we have x equals to square root of 5 raised to the power of 4. All right, so now we have x equals to, so you express square root of 5 in index form. That is 5 raised to the power of 1 over 2 raised to the power of 4. Now, you have been taught in your indices that whenever you have square root of x, it's going to be x raised to the power of 1 over 2. If it is cube root of x, it's going to be x raised to the power of 1 over 3, and so on. All right, so now the next thing is to use this power to multiply this power. All right, so x will be equal to 5 raised to the power of, now 2 goes here 1, 2 goes here 2, so that's 5 raised to the power of 2. All right, so you now have x equals to 25. So that's going to be the answer. All right, so how do you award mark? Now, for changing this logarithmic equation to initial equation, there will be a method mark 1. And for getting to this level where we have x equals to 5 raised to the power of 2, another method mark 1. And then for getting the answer, E1. So 3 marks. So mark that, and let me have your score in the comment section. All right, now let's look at the second question here. Of 32 base 8 equals to x. Now this is logarithmic equation, so you change it to initial equation. So this comes here. So we have 32 equals to 8 raised to the power of x. All right, so you express this in index form. That is 2 raised to the power of 5 equals to, now express 8 in index form. That is 2 raised to the power of 3, because when you multiply 2 in 3 places, you are going to have 8. 2 times 2 times 2, that gives you 8. So raised to the power of x. All right, so now we have 2 raised to the power of 5 equals to 2 raised to the power of 3x. All right, now you can see the bases are equal. So once the bases are equal, you equate the powers. So you have 5 equals to 3x. All right, so you divide both sides by coefficient of x, that is 3. So you have 5 over 3 equals to x. Now, so x will be, now 3 goes in 5, that's 1. It remains 2 over 3. So this is going to be the answer to the problem. Now, how do you award a mark here? So you have M1 for this, for changing logarithmic equation to initial equation, M1. And also for having 2 raised to the power of 5 equals to 2 raised to the power of 3x, you have another method mark 1. and for getting the answer, you have a 1. So that is 3 marks. Alright, so mark yourself overseas and let me have your score in the comment section. Alright, thank you. Now let us move down to the question for today, example 3. Alright, now we have log 1/3 base 1/9. We are to evaluate this. So how do you do this? The first thing is to equate this expression to an alphabet. So you start by saying let x be equals to log of 1/3 base 1/9. You get that? So now this is now a logarithmic equation. So you change it to initial equation. You know what to do? This base comes here. That's all. So we have 1/9 raised to power of x equals to 1/3. Okay? So now this can be written as 1/3 raised to power of 2 raised to power of x equals to 1/3. Do you get that? Now look at it. 1/3 square is the same thing as 1/9, because when you have 1/3 times 1/3, that gives you 1/9. Do you get that now? 1 times 1 is 1, 3 times 3 is 9. Alright, so 1/3 square is the same thing as 1/9. Alright, so now this power will multiply this. So you have 1/3 raised to power of 2x equals to 1/3. And this is the same thing as raised to power of 1. Okay, so now you can see the bases are equal, so you can equate the powers. So you have 2x equals to 1. 2x equals to 1. So you divide both sides by 2. So you have x equals to 1/2. So that is the answer to the first part of the question. Alright, now let's move down to the second one. Evaluate log of square root of 8 base square root of 2. Now how do you do this? You start by saying let x be equals to log of square root of 8 base square root of 2. Now this is the base, this is the number, and this is the power. So the base comes here. So you have square root of 2 raised to power of raised to power of x equals to square root of 8. You get that? Now you express this in index form and this. So now this turns to 2 raised to power of 1/2 raised to power of x. Now don't forget, when you have square root of x, your law of indices, that is going to give you x raised to power of 1/2. If it is cube root of x, it will be x raised to power of 1/3. If it is fourth root of x, that will be what? X raised to power of 1/4, and so on. Alright, so now this left hand side now will be 8 raised to power of 1/2 because it's square root. Alright, so now this half will multiply x. So we have 2 raised to power of x over 2 equals to, now you express 8 in index form, because my objective is to ensure now that the bases are equal. Alright, so we have 2 raised to power of 3. Okay, that's the same thing as 8. When you multiply 2 in 3 places, you're going to have 8. So now raised to power of 1/2. Okay, so we have 2 raised to power of x over 2 equals to, now when you use 3 to multiply half, you have 2 raised to power of 3/2. Hope you get that. Now the bases are equal, so you can equate the powers. So you have x over 2 equals to 3/2. Right? So now you cross multiply here. You have 2 to multiply x, so you have 2x equals to 2 times 3, that is 6. So here you divide both sides by the coefficient of x. So you divide both sides by 2. So when you divide this by 2, you have x. You divide this by 2, that's 6 over 2. Okay, so you have x equals to 3. So, and that is the answer to the second question. Now let's move to the third one. We have log of 1.69 base 1.3. Now let's solve the third question. Log of 1.69 base 1.3. Now the first thing is to assume that x equals to log of 1.69 is 1.3. Alright, so this is a logarithmic equation. We change to indicial equation. So this base comes here, so we have 1.3 raised to the power of x equals to 1.69. Right? So the next thing is to change this to fraction. Now, what's going to be the fraction of 1.3? That is 13 over 10. Because once you move the point once, so that means the whole number you have here, you divide by 10. Now look at this. The fraction of this is going to be what? 169 divided by 100. So I'm dividing by 100 because I will move the point twice to have a whole number. Okay, so now this now turns to 13 over 10 raised to the power of x equals to 169 over 100. Okay, so now when you look at this side, you discover now that this is a perfect square. This is also a perfect square, because this 13 times 13 times 13 is going to give you 169, while 10 times 10 will give you 100. So now, so this returns to let's say 13 over 10 raised to the power of x equals to 13 raised to the power of 2 and 10 raised to the power of 2. So you can write it this way. So when you square this, you're going to have what we have here. So 13 times 13, 169. 10 times 10, 100. Okay, so now you can see now that we now have the same base. Since the bases are equal, you can equate the power. So that means